Hey everyone, this is Shinju with Dystopia Labs. Welcome to day 2 of Playful, an NFT DeFi summit. We have Nader Dabbit from EdgeNode, also the Graph. He'll be doing a workshop on how to build subgraphs, and I'll let him take it from here.
All right. Thank you so much for the intro. Excuse me, and good morning or good evening, depending on where you are in the world. Thank you for showing up and checking this out. If you're in the US, it's pretty early, so thanks for getting up early and joining us here. If you're watching this later, thank you for checking it out. We have a lot to go through, so let me go ahead and just start kicking this off. My name is Nader Dabbit, like she mentions. I do work with EdgeNode, and one of the protocols we work really closely with is the Graph protocol. And that's what I'm going to be talking about today. I'm going to be giving a workshop, and I'm also going to be sharing this workshop material with you afterwards. So if you want to kind of follow along, or maybe I'll share it even earlier than that. But this is basically going to be following that workshop guide. And we're going to be looking at how to build a graph subgraph with the Graph protocol. And I'm going to describe what that means, like what a subgraph is and why you might want to actually know this and build one of these. And then we're actually going to build one from scratch. So the Graph allows developers to build and deploy open APIs on top of blockchain data. So let's talk about why that's important. Well, in a traditional database, you have the database that's optimized for both reading and writing data. But in a blockchain, you typically have, all these protocols are focused on write transactions. So you hear people talk about things like 1,000 transactions per second or 50 transactions per second, or maybe 100,000 transactions per second. Everything is optimized around writing this data, but there isn't really a lot of discussion around reading that data because basically this data is stored over time, over the course of hours, days, weeks, months, years in these blocks. So therefore, if you want to hit this back end, you could call it this database with this database that has its own special set of properties that is a blockchain. If you want to hit this back end, get information, it's not easy to query anything beyond a really basic read. So if you need anything like relational data, if you need anything like search, full text search, you need any types of doing things like filtering, sorting, joining, all of this stuff that you typically need for robust applications, it just isn't there directly. So in the past, what a lot of developers were doing is they were building out their own proprietary indexing servers. So you basically build out an API, you host it on AWS or something, GCP, you build a database, you store all this information, and now you have your centralized indexing and querying layer. And this works, but it kind of breaks a lot of the important security concerns required for true decentralization. But it's also very, very, resource intensive, both time and engineering wise. So subgraphs kind of bring to the table a solution for this. So let's talk about why, again, this is important. When you think about a search engine like Google, the reason it's valuable is that we have all this information around the world hosted on millions, maybe even more of different websites. And if you want to find this information, you can't just go around and kind of like hyperlink between different sites. So therefore, what Google does and what the value it brings is that it indexes all of this data and it stores it in a central indexing server. You could call it almost like a graph node. Which we're going to look at in a second. And it allows people to then just query that data. So it stores all of it. It makes it really easy for retrieval. The same thing like a Dewey Decimal System in a library. You don't have to walk through the entire library looking for this one piece of data. You go to this index, and you can kind of say, okay, this is where that data is. And I'm going to be able to retrieve it extremely easily because this is telling me exactly where this data is. A subgraph is like that, but it is, providing this critical piece of infrastructure in the Web3 stack. And it sits in between your UI and the actual smart contract. And developers can basically build these, and that's what we're going to be doing today. And they can deploy these, and they can then have an API layer that they can then use in their front end or their web or mobile application. Once this is deployed, you can basically have applications that can begin querying all this data. And instead of relying on a centralized service provider, and instead of kind of having this single point of failure, you're now able to have a query market that's comprised of decentralized network of indexers, and they're all competing to provide the best service at the best price. So you might have dozens or even more of these different indexers that are serving this data to your application, and therefore there is no single point of failure like in a centralized tech stack. The graph network operates using something called graph tokens, or GRT. And this is kind of a way for people and developers and participants to secure the network. And there are a few different roles. And I'll kind of go over those roles really quickly right here. So you have indexers, and indexers are basically the node operators. So if you're kind of a DevOps engineer, you can basically run your own indexer, and you can earn financial rewards for running this piece of infrastructure, and you're basically hosting these subgraphs. You have curators that basically stake the graph token to signal quality of subgraphs that developers are deploying to these indexers. So if I see a subgraph that I think is going to be valuable, I can basically curate or put graph token to back that subgraph, and I will receive a combination of curation shares as well as a portion of the query fees for the usage of that API. We also have subgraph developers. That's what we're going to be doing today. We're going to be building and deploying a subgraph. And you can basically say that you want to have a subgraph that you think is going to be popular, that people are going to use. You can basically build, deploy, and curate on your own subgraph and earn your own rewards based on people using that subgraph. And then we have delegators, and delegators allow people to kind of participate and help secure the network via backing indexers without having to have technical expertise. They don't have to run a graph node, but they can basically share in those rewards by using their graph token to kind of back a delegator. And the graph is, being used in all types of applications in Web3. A lot of the most well-known applications have subgraphs or are using subgraphs. Uniswap, LivePeer, Foundation. A lot of these pretty interesting applications are using the graph. So once you've deployed a subgraph, you're basically given in this API endpoint. So you have your subgraph, you write your code, you deploy it, and then the subgraph is deployed, and you get an API endpoint, and you can start using that in your app. And then you can just start hitting it with queries. And we're going to look at GraphQL queries in a moment. But you would just use this similarly to how you might use a regular HTTP endpoint. So if you've ever worked with REST, you've have this get, put, post operations. With GraphQL, you have queries, and you also have maybe mutations. But with the graph, you're just going to be interacting with the graph by querying it. So what we're going to now do is jump into this actual workshop. And if you want to follow along, or if you want to check this out later on, you can go to github.com/dabbit3, and you can look for building a subgraph workshop, or you can just go directly to this URL. We will share this for sure later on as well. So let's go ahead and start building something. So before we build, let's go to the graph.com and kind of take a look at the Graph Explorer and look at some subgraphs that are already deployed. So here we kind of see an overview of different subgraphs that are deployed, and these are sorted by the most signal. So these are kind of sorted by maybe what curators are seeing as the most valuable ones. So for instance, we have a SushiSwap subgraph. You drill into it, you get all this metadata and information about it. You can signal on the subgraph. You can basically query it. If you want to kind of build out a front end on top of this, you can get your query URL. You can also, get all of this information around the network information. But you can also go to this playground, and the playground allows you to run queries. So let's say we wanted to just go ahead and test this one out. We could do something like this. We could say, let's get tokens, and we might want to say the first 5. And what information does a token have? Well, we can just actually click over here and see, okay, it has an ID, it has a name, has a symbol, and it has like a total supply, and it has a bunch of other stuff, right? But let's just get this information here. So we can go ahead and test this out. Here we see we have the token ID, we have the token name, we have the supply, and all of this stuff, and the symbol. So this is kind of like a subgraph that's already been deployed, but let's now deploy our own subgraph. So to do that, I'm going to go to the graph.com, and I'm going to go to right here in the top right hand corner, Subgraph Studio, and it's going to ask me to authenticate with my Ethereum wallet, and I have already authenticated. So this means that I'm kind of like signed in using MetaMask, and I'm going to click Create a Subgraph. And we have 19 minutes, so let's see if we can get this subgraph created. So the subgraph that I'm going to create is an NFT API, and it's going to be for querying data from the Zora marketplace, NFT marketplace. So Zora, you go Zora.co. You have all these NFTs and stuff. What we want to basically do is kind of build out our own API that uses this smart contract essentially to kind of build out our own endpoint. And index this data ourselves. So we've created this subgraph in the dashboard, and now we can use this to kind of bring down to our local development environment to actually write all this code. So we're going to need this subgraph slug in a moment, and we're going to need this deploy key. You also can see that you can kind of set metadata. You can also see some instructions around using the graph tooling. So we have open source tooling like CLI and other stuff. All right, cool. So we have this API ready to go. So let's now go to our terminal. And here I'm in an empty directory. And basically what I want to do here is I want to initialize a new subgraph. So to do that, I can install the Graph CLI, which would be like npm install -g, Graph CLI. And then after that, I will be able to have the graph binary. And I can now use graph to say like graph, and do stuff. So the stuff that we want to do is initialize a new subgraph. So the way that we can do that is we can say graph init, and then we can pass in some values. So to do that, we're going to say graph init, and we're going to pass in a few different things. So first of all, we're going to use the smart contract for Zora, which is available in Etherscan. And to do that, and to kind of reference this smart contract, all we have to basically do is pass in a flag for the contract. And I'm going to actually zoom in a little bit just to make sure that people can see my text, because I understand that I have a pretty wide screen here. All right, there we go. So what I want to say is graph init, and I'm going to say from contract. I'm going to paste in the contract address. Next, we're going to also say we want a few other pieces of functionality. We want to say -- index events. This is basically going to look in the smart contract ABI and find the events that are emitted from the transactions. And we can basically listen to those events and get the metadata out of those event calls and use that to kind of index our data. We can also say we want to specify the contract, because a individual deployment address might have multiple contracts. So for instance, you might have a token and a marketplace or additional contracts that have all been deployed in a single deployment. And the last thing we want to do is say -- studio, because we want to specify that we want to use Subgraph Studio versus the other graph product called the hosted service, which is not a decentralized service, which was kind of like the legacy initial version of the graph before the decentralized network was deployed. So using this set of commands, we should be able to go ahead and deploy this thing. So next, it's going to ask us for our slug, and we can get that right here by copying that to our clipboard and going back. And the directory, we'll just take the default. We can choose the network. We want to index Ethereum mainnet. The contract address has already been passed in. The contract name is there. And this should go ahead and scaffold out the code that we need to go ahead and get us started. And this should only take a couple of seconds. All right, so now that we have our subgraph created, we should be able to change into this directory and see that we have all this code that's created for us. So what we want to do now is just go ahead and open this up in our text editor. All right, the things that were given by the Graph Cli are all this code here, of course, but there's three main things that we're going to work on that we need to kind of build out a subgraph. One is the Graphql Schema. That's right here. We're given some example code. The Graphql Schema is essentially your data model. So what data do you want saved in your API? So for something like an NFT API, you have an NFT, which is a non-fungible token. So we might want to have a token type. In addition to that, we might also want to keep up with the people who are owning these tokens. So we might want to create a user type. So let's say that we want to have both of those. Those are going to be the two types that we're going to create. So we're going to delete all of this code and we're going to add that later. The other two things that we have are the subgraph.yml. The subgraph.yml is basically the main configuration of your subgraph. We're going to walk through this in depth in just a moment. And then the last thing we have are these mappings in the Src directory. And this is kind of where we write our own logic. So if we decide to save a token, what information do we want to save about that token? We might want to save things like when it was created. We want to save the metadata URI, the content URI, all of that stuff. That's where we're going to actually define and do that actual writing our own code and that logic here. And this is kind of going to be where most of the code that we actually write lives. So with that being said, let's go back to our GraphQL schema and go ahead and define our data model for our user and our token type. And I'm just going to go ahead and paste this here to make sure we get it right. So the token type uses this @entity directive, which is specific to the Graph CLI, and we can basically use that directive to specify that we want the graph node to kind of save this and make it queryable. And we're going to get all of the functionality like filtering and sorting and all that stuff. You can also add full text search within maybe 10 lines of code or something in your schema. We're not doing that here, but it's pretty easy to do. Just check out the docs. But for the token, we basically have all this metadata. So when we query for a token, we want to get the content URI, the metadata URI, the created at timestamp. We want all this information. So we're kind of saying, these are the key value pairs. And this is GraphQL schema definition language. But if you've ever used any typed language, it should look very similar. If you've ever used TypeScript, this should be pretty similar as well. The other thing that we have is our user type. And an interesting thing to note here is that we're also enabling these one-to-many relationships between a creator and a user, between a token and a user using this creator field. And the way that we do that is we have this second directive called @derived_from. By using this directive, we can pass in the field from which that relationship is derived. So in this case, we want to create a one-to-many relationship between tokens and users. And the reason that we do that or do this is that we can now have a pretty interesting querying capabilities, because we can say we want to get all of the tokens and their users, or vice versa. We want to get all of the users and their tokens. Or we might want to query a user by ID and get their tokens. There's all types of stuff you can do. Pretty cool. And you can kind of make this work without using a ton of code. So with that being said, we can now go to our subgraph.yml. And what I'll first want to do here, just to make this a little bit more concise, is delete some of the boilerplate that we're not going to use. So by deleting this code, we're now left with about 24 lines of code. And if I kind of try to fit this into the window, you can kind of read through some of this information here. And if you kind of take time to read through this, it will actually probably make quite a bit of sense what is going on here. We're defining we're basically defining for the graph node where we're kind of deploying this subgraph, what we want that node to do with this subgraph. So we're saying, okay, we want to use Ethereum mainnet. The address for the contract that we want to index is this address. The ABI, which was automatically downloaded for us, or we can manually add it here, is the token ABI, and it's it's already been created for us automatically. We also have these, I guess, two main parts would be the entities and the event handlers, and this is kind of where we're going to continue off with what we did in our GraphQL schema to make this work. So for the entities, we want to define which entities that we want to save and make queryable. So for us, that's the token and the user, right? Because we created a token and a user. So we want to now index the token and the user. So those are the two entities that we want this subgraph to save. We also have these two event handlers. And when we passed in that index events flag to the Graph CLI, it automatically populated the event handlers fields for us because we have the ABI. The ABI defines the events. So therefore, the Graph CLI can just say, oh, okay, we see that we have like these 5 or 6 events. Let's go ahead and create some boilerplate code for you so you don't have to write this yourself. So we can literally use these two event handlers as they are written here in our Subgraph Yml to then create our mappings, which will be the actual handler functions. So to kind of make this slightly more clear, when a transaction happens on Ethereum, if you have written any Solidity, you've probably worked with these events, and you can emit an event when some type of state change happens, or even when any type of transaction happens. So here we're basically saying, okay, when a token URI has been updated and that event has been emitted, we want to handle that event by invoking this function. When a transfer has happened, when someone transfers a token from one person to another, we want to invoke this function. And then in this function, we're going to be getting these 3 pieces of information passed into the function handler. And then we can now handle that ourselves in the mappings. And that's where we're going to be writing our code. The last thing we might want to do is here in the source, we can also define a start block. And this is basically going to be like when it was the first transaction that ever happened. Because if we don't define this, it's basically going to start indexing Ethereum from the Genesis block. And this is really easy to find on Etherscan just by going to the address and kind of looking for it. So we want to go ahead and just set that start block. And now we can go to the last step, which is our mappings. And this is, again, going to be where we write our business logic. But before we write this, we can actually generate some helper code based on our GraphQL schema. And the way that we can do that is we can go to the CLI and we can say graph code gen. And this is going to look in our GraphQL schema, and it's going to generate some code for us in this generated folder. And the code that it's generated for us here allows us to interact with 2 different things. One is going to be the graph node itself. So what happens if we save a token and we want to retrieve that token metadata later, or that token later for whatever reason? This will give us functions that allow us to talk to the node. It will also give us functions that allow us to talk to the smart contract itself. So let's say we want to, in one of these event handlers, talk to both the graph node as well as the smart contract. We can do that. And we can do that using these helpers that were created for us. And without going into all the details there, it's basically leveraging 2 open source, or actually one open source library that's created and maintained by the Graph called the Graph TS or Graph TypeScript. All right, so let's go ahead and import some of these different helpers. So the first thing we want to import is going to be these events that are going to be, well, actually not only the events, but also a reference to the token itself. And this is going to be relating mainly to the actual smart contract, or it is going to be only relating to the contract itself. So we can have type safety by having these events, as well as a way to talk to the token contract itself. And then the user and the token coming from this file here allow us to talk to the graph node. So we can use those pieces of functionality to talk to the graph node, as well as the graph, as well as the smart contract. All right, so let's see here. The next thing that we want to do is let's go ahead and create the function for handling the transfer of a token. So the way that we're going to do that, I'm going to go ahead and paste in these 20 lines of code here. And this is going to be the longest function by far. The other one's going to be much shorter. We have a handle transfer event. And this is basically going to be invoked when someone transfers a token. And, this is quite a bit of code, but let's just quickly walk through it. The first thing we do is we try to load a token from the graph node. If the token does not exist, we go ahead and create the token and set metadata on it. So we set like the creator, the token ID, the created at timestamp. We then call out to the smart contract and we get the content URI and the metadata URI. We then save the token, okay? And then finally, we also do the same thing with the user. We try to load the user. If the user exists, we're good. If it doesn't, we go ahead and create the user. So all that just happened in that one function. And then the other function that we have to deal with is the token URI updated. So if someone decides to update their token URI for whatever reason, we can basically handle that. And what we're going to do is load the token, update the content URI, and then just call token.save. This token.save function saves the updated content to the graph node. And then the last thing we might want to do is we might want to say, like, if there is no token, just return. All right, so with that being said, we should be able to go ahead and deploy this and test it out. So the way that we're going to do that is we're going to go to our CLI, and we want to run a graph deploy. We can say -- studio. And then here we want to pass in the name of our subgraph. So for us, it was NFT API. Here it's going to ask us for the version. Let's just say 0.1. Let's see how long this takes. Shouldn't be very long. Because we have 2 minutes left. So we want to make this actually happen while we're still here. It looks like I'm running into some issue right now. So let's see what's going on. It looks like there might be some issue. Let's see here. It looks like the actual our website is possibly down at this second. So I'm not sure if this is an error or not. So let me just try this one more time. And if this doesn't work, then we're kind of out of luck on this, which is kind of like really interesting considering we just tested this out. We were in the Subgraph Studio just a few months ago. Oh, it looks like it says it's already been deployed. So let's try a different version maybe. Yeah, it looks like there's some type of issue right now with the actual service, the website itself. But we actually got to the very end of the workshop, so I'm assuming this will come back up in the next few minutes. It's just very unfortunate timing. But yeah, that's kind of the end of my workshop. But if you want to kind of like follow along and test this out, check out the graph.com/blog, and you'll see a blog post called Building with Subgraph Studio, or check out that GitHub repo I shared earlier, and you should be up to, you should be able to get up and running. And hopefully in the next few minutes, whatever issue that we have will be fixed. If you want to learn more about the Graph, check out the Graph Protocol on Twitter. Thegraph.com is our website. Docs. We have our own Discord server, and we have a lot of activity there, and we encourage you to come hang out there. So with that being said, I think that is it for me. So I'm going to go ahead and stop sharing my screen.
Yeah, this was a really fantastic talk. Thank you so much for your time.
Thank you for having me. Thanks for everyone for checking this out.
Awesome. Okay, we're going to transition to our next session now. Thanks.